6.6 trigonometric equations. So we're solving the equation. We're solving for x. What is x equal to? And it's going to require some algebra, and it's going to require some trig. So they're just like algebraic equations, but generally a variable will be represented by a trig function. So if I was asked to solve x squared minus x equals 0, well, we can factor out an x, and then the zero product property says, well, each of these could be 0. So x equals 0 and x minus 1 equals 0. Well, that's already a solution. So x equals 1. Our two solutions would be 0 and 1. But in this case, it's sine of x being squared minus sine of x. So again, we can factor out a sine x from each term and be left with a sine x minus 1. And like here, we could set each of those, you want them factored so that you can set each of them equal to 0. And then we can just solve it. Okay, so what is x? If the sine of the variable, or of the angle, is equal to 0. So you could do an inverse sine if you want. So x equals, when is sine equal to 0? Well, on the unit circle, sine represents the y value. So where is the y value 0? It's right here at 1, 0, and right here at negative 1, 0. So there are two solutions from 0 to 2 pi. That's the domain of x. So all of our solutions are going to be between 0 and 2 pi. Sine is 0 at 0 and pi. So we have two solutions so far. Okay, I know that the inverse sine of 0 is 0, so that does not help us find the other solution. We're finding all solutions from 0 to 2 pi. Alright, so we have one more equation here. I'm going to add 1, so sine x equals 1. When is sine equal to 1? Well, on the unit circle, sine is y value. It happens right there at 90 degrees, or at pi over 2. So we have three solutions. We have 0, pi, and pi over 2. So you could double check sine of 0 squared, well, sine of 0, 0, square root of 0 minus the sine of 0, 0, 0 minus 0, 0. It works. You can plug pi in, you can plug pi over 2 in, and you get all three of them are solutions. Another example, again, our domain is from 0 to 2 pi. We don't have, well, we could factor it, or we could solve using square roots. There's actually two ways of doing it. I'm going to solve using, well, maybe I'll factor first. So this is a difference of squares. What's being squared here is 2 cosine x. What's being squared there is 1, so 2 cosine x plus 1, 2 cosine x minus 1, and it's factored, so we can set each of those equal to 0. So 2 cosine x equals, or plus 1 equals 0, and 2 cosine x minus 1 equals 0. So subtract 1, divide by 2. Okay, when is cosine negative 1 over 2? When is cosine negative 1/2? So cosine is negative in quadrants 2 and 3. So negative 1/2, negative 1, 2. So that means this is square root of 3, negative 1, 2, square root of 3, negative. So these two angles right here, this angle and this angle, have a cosine of negative 1/2. Well, how big are those angles? Well, we know the reference angle is 60 degrees, which means this angle is 120 degrees, or 2 pi over 3. And the other one has another 60 degree reference angle, or 4 pi over 3, because that's 240 degrees. So those are two answers. We still have another equation here, so add one. So 2 cosine x equals 1, so cosine x equals 1/2. When is cosine 1/2? Well, cosine is positive in these two quadrants, so we have two triangles to work with. Cosine is 1/2, so 1, 2, square root of 3, negative square root of 3. Okay, so how big are our angles? There's one right here, and here's one right there. This is 60 degrees, or pi over 3. And then the other one, we can't go backwards. We don't want to go backwards 60 degrees because our domain is from 0 to 2 pi. So we're not going negative, we're just going from 0 to 2 pi. So we go all the way around 300 degrees, which is 5 pi over 3. So we have four solutions: 2 pi over 3, 4 pi over 3, pi over 3, and 5 pi over 3 to that equation. I told you right away if you did not want to factor, you could solve it using square roots. So I could add 1, divide by 4, and then square root. So cosine x would be plus or minus the square root of 1/4, which is plus or minus the square root of 1, which is 1, square root of 4, which is 2, plus or minus 1/2. Okay, so where is cosine 1/2 and where is cosine negative 1/2? And that's where these two triangles come into play. We actually have four different solutions: when it's positive 1/2 and when it's negative 1/2. So you'll get the same solutions whether you solve it this way or if you factor it. So from 0 to 2 pi, those are our four solutions. All right, two more examples for this video here. So it doesn't, you could again solve using square roots, or you could solve by factoring. I am going to solve using square roots this time because a difference of squares, we would have to have a square root of 2 sine x is what's being squared there. I think it's just going to be a little bit easier to look at it by using square roots. So I have sine squared equals 1/2, and we square root, and anytime you square root, it's going to be plus or minus. So it's plus or minus the square root of 1/2, which is plus or minus 1. Okay, so where is sine x equal to 1 over square root of 2? And when is sine x equal to negative 1 over square root of 2? Well, sine is positive. In the top two quadrants, it's 1. This is like a bow tie problem. There's four different triangles. The positive, when is sine equal to 1 over square root of 2? 1, square root of 2, 1, square root of 2, and we're looking for those angles. So that's 1, that's a negative 1. And then when is it negative 1 over square root of 2, negative 1 over square root of 2, negative 1 over square root of 2. So we have this angle, this angle, this angle, and that angle. Four different solutions. So these are all 45-degree reference angles. So that's a pi over 4. This is a 3 pi over 4. This is a 5 pi over 4. And a 7 pi over 4. Those are my four solutions to this equation. That's again from 0 to 2 pi. That's all I'm doing in this video, is talking about from 0 to 2 pi. Last example, I'm going to divide by 2 here. So you may have noticed that this is a cosine of 2x. It's a double angle for cosine. Okay, So imagine, when is the cosine equal to 1/2? When is cosine equal to 1/2? So that happens to the right side here. When is it 1/2? Right here. This angle and the one all the way around, that's when it happens. Okay, so that would be at 60 degrees, which is pi over 3, and 300 degrees, which is 5 pi over 3. Okay, so I'm still ignoring the fact that it's the cosine of 2x. I'm thinking of it as cosine of x. Now that I've done that, I set, like right here, I had sine x equals -1/2, so then x equals that, and x equals that. But here, we just found the cosine of something gives you 1/2, but it's actually 2x. So 2x equals pi over 3, and 2x equals 5 pi over 3. Well, we're solving for x. We don't want 2x, so I have to divide by 2, or multiply by 1/2. And x equals pi over 6. That's one solution. Divide by 2, or multiply by 1/2, we get 5 pi over 6. We have a second solution. Alright, so normally we would be done because those are the two times that cosine is 1/2. But since it's a double angle, it's actually going to do double the amount of solutions. Like on our graph, that cuts our period in half. That's our b, if you remember that. So a normal cosine curve would look like this. If that's with a period of 2 pi. If we have a b of 2, it's now 2 pi over 2, which is pi. So the new one would be like that, and then it would repeat itself like that. There's actually 4 times that the blue one hits in that interval from 0 to 2 pi. The red one only has 2 solutions, like these two, but since there's a 2 there, that's going to double our amount because it changes our period. So when is the next time that cosine is 1/2? We just found the only 2 times from 0 to 2 pi. But if we went all the way around the circle, like this, well, how big an angle is that? That's 360 degrees plus another 60 degrees, which is 420 degrees, which is 2 pi plus a pi over 3, so that's 7 pi over 3. And then the next all the way around again, so it's 360 plus 300 gives us 660 degrees. And if we change that to radians, we would have 600, you could go multiply by pi over 180. So if you don't know that, your calculator will basically do it for you. 660 divided by 180 equals bracket, so it's 11 pi over 3. Okay, so we divide by 2, so x equals 7 pi over 6. Divide by 2, x equals 11 pi over 6. We could go all the way around again, but our answer is going to be beyond 2 pi, so we do not have to do that anymore. This doubled our amount of answers, so we got these original 2, and then I got 2 more. So what you could do is just our original pi over 3, you could just add 2 pi to it, which is 6 pi over 3. That gives you 7 pi over 3. Add 2 pi to that, which is 5 pi over 3 plus 6 pi over 3 is 11 pi over 3. So just add 2 pi. That's why we went all the way around again to our initial angles, and then you're just going to divide by 2, and you get your answers.